The formula for exponential growth can be modeled by this equation here. So y, the future amount, is equal to c, the initial amount, times 1 plus the rate of growth, quantity raised to the number of time intervals. We'll use this for example 1. In 2000, a town named Bryan had a population of 74,700 and was consistently increasing by 0.2% each year. If this continues, predict the city's population in 2020. So we've got some numbers here. Let me just underline those. And let's start labeling them. So 2000 is the beginning of the time interval. And 2020 is the end of the time interval. So that means the time interval is 2020 minus 2000, which is 20 years. The population in 2000 was 74,000. That's the initial amount. And it's increasing by a rate of 0.2. So divide that by 100, and that's 0.002 for the decimal. All right, so we want to predict the population in the future. So that will be y. We'll be looking for y when c is 74,700 times 1 plus the rate raised to the number of time intervals. So this is something we're going to put in our calculator, and if you have a graphing calculator, it just goes in right the way you have it. If you don't, you have to add first. In the order of operations, do what's in the parentheses, then raise that to the power, and then multiply by the beginning number. And the answer that we get is 77,745.45909. But let me tell you, people don't come in decimal form. So I'm going to round to the nearest person and always round up. Always round up when you're talking about exponential growth. So 77,746 people. That'll be the population in 2020, expected population based on this rate of growth. Number 2, National Park Service personnel are trying to increase the size of the bison population of an Australian national park. If 430 currently live in the park and the growth rate is 2.5% annually, find how many bison will be there 10 years from now. So there's a growth rate, right? And if we divide that by 100, that's 0.025. So I know that this is exponential growth. I'm going to be using the formula for exponential growth. Let me underline some numbers here. Find how many in the future, so that's y. That's what we're looking for. Currently, there's 430, so that's the current population. We got the growth rate. And the number of time intervals, they give us straight up 10 years. So let's put that into the formula. Current 430 times 1 plus the rate raised to the number of time intervals. So again, this is how we're going to put it in our graphing calculator. Otherwise, add first, then raise to the power, and then multiply by the 430 to get your answer in a scientific calculator. And we should find that is 550.436, etc. But again, this is population, so we need to round to the whole number and always round up. So that's going to be 551 bison in this park 10 years from now. So the question that I asked you at the beginning about how much money you would have at the end of 30 days, do you think you can use this growth equation to write that as an equation, an exponential equation? I'll show you the answer in the summary video.